السلام عليكم ورحمة الله وبركاته. ايه الأخبار يا شباب؟ طيب إيه الناس جت ولا لسه؟ اهو شايف أعداد ابتدت تظهر. فالناس اللي موجودة كده تقول لنا هي بتتابعنا منين؟ يا ريت نعمل واتش بارتي بقى وشير وكل الحاجات الحلوة دي عشان الايفنت يروح لأكتر ناس ممكنة. عشان نبدأ معانا النهاردة سيشن تقيلة قوي هقول لكم عليها حالا. استنى بس دقيقة كده الناس تيجي. ايه يا شباب ما فين الكومنتات؟ مش شايف حد لسه كتب حاجة. طيب ممكن على ما الناس تبتدي تيجي نبتدي نعرفكم بالسيشن بتاعت النهارده. اهلا وسهلا مرة تانية في ايفنت جديد من جي دي جي حلوان. معاكم النهارده انا محمود حسين اندرويد ديفلوبر واورجنايزر في جي دي 1. اهلا بيكم في اليوم الرابع من ساوث كايرو تيك توكس من اصل 14 يوم زي ما انتم عارفين. باشمهندس طارق قال لكم امبارح واول. ساوث كايرو تيك توكس بتقدم لكم جي دي جي حلوان بالتعاون مع دي اس سي مودرن في الكمبيوتر ساينس. هنقول بس حاجة صغيرة كده. quick disclaimer. Hello everyone and welcome to GDG Helwan. Welcome to session 4 of South Cairo TikToks. If you are watching us globally, don't worry, the session itself will be in English. This is just an introduction, so bear with us. الناس ابتدت تيجي. هقول لكم حالا على السيشن عبارة عن ايه. طيب هي السيشن اللي معانا النهارده سيشن قوية جدا والكونتنت بتاعها مش سهل تلاقيه اونلاين في اي حتة. السيشن بعنوان and libraries stop starting up. يعني ايه بقى الكلام ده؟ هي طبعا هيكلمنا في السيشن باشمهندس نيشان من المانيا. هيكلمنا عن الاندرويد لايبريز اللي بنستخدمها دايما في البروجكت بتاعتنا بتشتغل ازاي. هيعرفنا هي بتشتغل ازاي وايه الهاكس والتريكس اللي اللايبريز دي بتعملها عشان تتسابق وتران بسرعه على قد ما تقدر، وعن ايه بقى المشاكل اللي ممكن ده يسببها في البروجكت بتاعنا، وازاي ده ممكن يزود الران تايم بتاع الاب بتاعنا. وهيعرفنا كمان الاهم من ده شويه من البيست براكتسز والسوليوشن عشان نحل الموضوع ده. ومعانا دلوقتي برضو سعان باشمهندسة إشراق من دي اس سي مودرن اكاديمي فور كمبيوتر ساينس. هتعرفنا في نفسها برضو وعن دي اس سي، هتقدم لنا السبيكر بتاعنا النهارده باشمهندس نشانت. فأسيبكم معاها، اتفضلي يا إشراق.
Hi everyone. Can you hear me? Hi everyone. Hello and welcome to our fourth session at the South Cairo TikToks event. I'm Ishraq Ahmed, the DSC lead at Modern Academy in Maali. And today we have a very special guest who is Nishant from Berlin, Germany. He is an Android engineer and with experience building Android applications and SDKs for the Android platform. And he's also an open source enthusiast and contributes a lot to the community. Today, in this session, we're going to talk more about the libraries and why you should start using them. Okay, Nishant, you can go ahead. Welcome, and we're glad having you there. Nishant, you can go ahead. If you're ready, go ahead.
And today I'm going to be talking about Android libraries in general. So I personally have had this experience working as a library developer. I have some of open source libraries, and then I've also worked with closed source libraries. And then I've also been on the other side where I've integrated Android libraries. So what that means is that in overall, I have the experience on both sides, and that has led me to notice some different things that Android libraries do. So today we are going to be talking about Android libraries in general, and then like what are they doing within your application? How are they starting up, and how are they going to be affecting your, say, initialization and your startup time in general? But because we are talking about Android libraries, the first question that we should have is that why are we even talking about this particular, say, topic in general? Well, the thing is that Android libraries in general have many ways of initializing itself. Some of them are good, some are bad, and then there are some of them are like okay. There something depends on your perspective. The end result of all of this is that it's mostly chaotic. There's many of the different ways of doing this, so everyone is doing their own version. So out of this talk, actually, we want to understand that how can we unify the fragmentation? What can be done to unify this fragmentation? To understand this whole fragmentation problem of like having different ways of initializing Android library, we need to understand how do they do this, right? So initializing how is what we are going to first explore. So some of the examples are going to sound like they are super easy and like you don't kind of have to, like, you already know about it. That's true. But in general, what we'll do is that we'll step up from understanding how the general works with the simple version works, and then how do you move on to a more complex version of initializing a library. So let's start with the most basic example, that is using a normal class constructor. We all have kind of created classes, so this is nothing new. I'll explain the example first, which we will kind of use in across all the other versions of this, right? So my library right now, my lib is a class that I am going to be putting inside my Android library. And what it does is it takes a token as a parameter through its constructor, which is of string type. Now, what this example is actually doing is that it kind of creates an authorization header, which you will probably put it using retrofit. You will use something that kind of makes a request, and you want to add a certain header to it, right? So what we have here is that we have a property called start string, which is a standard string. It's a constant kind of, it says authorization bearer, and then there's a space on it. And then what we do is that we also create another property called auth header, and that is now initialized with the start string. Notice there's a section here that goes by the block of init. And what it's going to do is that this is a Kotlin way of doing something, that whenever you create the instance of my lib class, the init block would be called. And what it is doing is that it's actually calling another function that is available to you, and this is called change token. Now, change token does very basic thing. It concatenates the string. It takes the start string, it takes a token, and it concatenates them. Then you also have another function called get auth header, which is kind of just a getter for the auth header property. So the example is pretty simple. We are kind of creating an authorization header string, which would ideally read authorization space bearer space and then the token number. So when we want to use this in our activity, this is how we'll do it. We'll basically create a property called mylib and then instantiate our class mylib and pass in through the constructor the token value that we want to pass. And then when we want to get it back, we'll basically say mylib.getAuthHeader, which is basically using the getter function that we have with our library. Also, technically possible is that you can also change the token before you get the auth header. So in this case, what we are doing is that we are basically calling change token with another token value, which is 456. That's why when we try to get the value, the returned value is authorization space bearer space 456. Pretty simple example. Now, another way of doing this is by using the init function. So what we are doing is that we have basically got rid of the constructor and the init block, but now we have the same example. Instead of the init block, we are using a standard function. This function is called init function, does the simple thing. It's called init, passes an argument called token, and then calls a change token as it would do earlier also. So this is the highlight. This is the main change that we did. We got rid of the init block in general. Now, in order to use this, we'll do the same thing again. We'll create a mylib property again inside main activity, and we'll instantiate without passing anything through the constructor. And because we are not passing anything through the constructor, it means that we need to specifically call the init function. That's what we do. We do mylib.init, and then we call 1, 2, 3. And then as a possibility, we can also change the token. So we also call change token 4, 5, 6. And then eventually we just use the getter to get the value back. Again, the output is same, example is same. It's just a different way of initializing the mylib class in this case. Another version of actually initializing is a deferred version, is by creating or using a lifecycle observer. Now, in order to use lifecycle observer functionality, you actually need to have dependencies. This is something that comes from the AndroidX Library domain. So you need to have something called lifecycle runtime.-ktx in your library modules build.gradle file. So I'm using runtime-ktx, and then I'm using common Java 8. This other one, the common Java 8, is basically used to get a specific class, which I'm going to show how we use it. So the one that we actually wanted to get was called default lifecycle observer. This is the preferred version now. And what it allows me to do is that I'm basically kind of implementing the default lifecycle observer, and it allows me to override the onStart and onStop. Okay, the example is still the same. The difference is that there is no init block, there is no init function, and instead of any of those, what we are saying is that when the lifecycle of the lifecycle owner goes into onStart, we'll call change token. Okay, but when it goes into onStop, we'll call reset. Now, reset is a new function, so let's take a look at what it looks like. Basically, same stuff, except in this case, we are saying auth header is equal to start string, so we are getting rid of the token part. Everything else is the same. Once you have actually implemented the default lifecycle observer on our class, we need to now start using this, right? So we're going to create a property, simple usual stuff that we do. We'll say mylib, and then we'll pass it 1, 2, 3 in the constructor. But notice that in this case, when we are passing it through the constructor, there is no init block, there is no init function. So nothing is actually getting properly initialized, as I would say, right? What will happen is that the initialization would be deferred to onStart of the main activity. This is why we implemented the observer. Someone is going to be observing the lifecycle and only triggering the change token when the onStart is called. Now, because this is a library and this is a code that we can anyways continue calling change token, so in the onResume, considering the whole initialization has already gone through onStart, by the time it gets to onResume, we can call a standard change token, and then we can get the value using getAuth header. Again, the output is going to be same. The initialization has been deferred to a later time based on the lifecycle. However, it's not as simple as to integrate, because we are talking about lifecycle, and lifecycle are notorious in general. So this code in general is showing how you actually initialize the library, and then you try to change the token. You're basically acting on the library, but it's not showing how the library actually hooks into the lifecycle. So to do that, what we do is that we basically have to add lifecycle.addObserver in the onCreate, and then on the onDestroy, we have to add removeObserver. And both of these are going to be adding mylib as the observer on the lifecycle and removing mylib as the observer, which is an extra wiring overall. So this is something that basically something that the app developers need to do when they are integrating a library which has lifecycle observer functionality. Now, I'm not making this all up. Basically, there are libraries that actually do this. This is an example. This is an old example, but I'm basically mentioning that some of the libraries that you actually use out there, SDKs that you use out there, have been doing this over a period of time. They've just evolved over a period of time. So you probably didn't see it, but at some point in time, they did try out these functionalities or these different ways of initialization. So Picasso, for example, added lifecycle awareness to itself in 20 August 2018. This PR was merged. And what it did was it would initialize Picasso at a certain point in time of the life cycle. They don't do that anymore, but some point in time, they basically approach this initialization process for the Picasso library in general. Okay, so we are talking about 3 different versions now. The other version that we can also think about of initialization is using a standard singleton class. In Kotlin, you do that by using the object keyword. So in this case, you basically have mylib as an object class, and the rest of the stuff is kind of same. But we are going to modify the code this time, the example this time a little bit. What we are doing is that we are basically using an init function, but instead of directly calling change token with the token string inside it, what we are saying is we're going to be getting the string from the string.xml file. Okay, string.xml file has a string starting underscore string key with a value that we'll see just now in a bit. And using the context, I can get the string from the string.xml. This is a normal process. A lot of libraries would require context to get some information from one of their resources or something related to the Android classes. So they will kind of want to initialize this start string as soon as they are set up, right? So the starting underscore string, actually, it lives inside the string.xml file, and it represents exactly what we had as a property. It says authorization : bearer, and then obviously we have our own function set up for change token and doing different changes to this. So now, in order to use this singleton based initialize library, the way that we do it is that we kind of have to set mylib as the standard class. Now we are not going to create an instance, but rather we are going to be calling the init function by passing it the context. Simple stuff, because we need the application context to get the string value, so we are passing it in there. And by the time we go and call change token with 1, 2, 3, the string value had already been retrieved. So the concatenation would work out and we would get authorization : bearer 1, 2, 3. But because we go and call change token again with 4, 5, 6, the final output though is authorization : bearer space 4, 5, 6. Again, super simple stuff. But notice there's a different extra wiring again, right? Like we had one for LifecycleObserver based initialization, there's another one for singleton class. Now, singleton class setup is pretty common, by the way. And I want you to focus on this part of extra wiring, because application context is something that the Android system should have provided you. And like you, as an app developer, shouldn't need to do this, okay? But anyways, there are other libraries that do this. For example, Coil, which is an image loading library for Android, backed by Kotlin coroutines, is pretty well known, has, I think, 5.5 thousand stars on GitHub, and like a lot of people actually use this now. It uses singleton class to do a bunch of different things. Like in the source code, if you go and check out, the standard coil class is basically an object class. And there's a link that you can check out. Basically, this lives inside coil-singleton module. And inside that, if you go and check coil.kt file, you can see the same source code. And coil basically tries to use this singleton pattern to do a bunch of like setup that they would want for image requests, for image loader and other stuff. So there are libraries that are using this. It's not something that's out of the picture, but basically many libraries would prefer it. However, understand that coil also uses a builder pattern. So it kind of does something related to constructor pattern, where it builds its base initialization code. So it does multiple things. It does use the builder pattern also and singleton class also. It has different ways. What it suggests you to do is that if you don't want to use singleton class, then you just don't include the dependency and rather use another one and then build your own instance out of it. So it gives you best of both worlds. It says you can use the singleton if you want to, but if you don't want to, then you can also use another one, where it's a very standard way of setting things up, a standard constructor or a builder pattern based initialization process, which is a good approach because it gives you options. But this was not it. At this point, we were talking about there's an extra wiring code that we had to write for application context for initialization. And that's something that people started thinking about. And they said, why can't we use ContentProvider for getting rid of that line of code, the initialization process of the library for the application context. And this was kind of publicized by Firebase. So this is in December 21, 2016. Firebase published a blog post talking about how they initialize Firebase on Android. Now, this blog post was kind of the first one that started talking about using ContentProvider to initialize your library because they needed application context, or they needed standard context for their library. Okay. The summary of this blog post, you don't have to go and read it. If you want, you can read it later on. But the summary is that basically the reason they can use ContentProvider is because the ContentProvider is created and it is initialized on the main thread before all other components, even before the application class. Okay. It participates in the manifest merging at build time. And for app developers, it takes away the initialization step of a library during integration. These are statements. Let's try to put this into practice and figure out how different this is. Okay, so we're going to actually try to use ContentProvider trick to understand how we can initialize our library. So in this case, what we are going to do is that we are still using the singleton pattern of our library. We have a mylib object class, and we still have the init function. But now we are going to be creating an init provider, mylib init provider, that extends from ContentProvider. What this allows us to do is that it gives us access to override on create, and inside on create we have access to context. So this is where actually we can call mylib.init context. This class in general is living with your library code, but this is not all that you have to do. There's an extra wiring code that you also need to do, and this is inside your library's manifest file. So what we are doing is that we are basically putting in a provider tag inside it. And what it does is that it has the Android name is set to the class that we just created, mylib init provider. And then it has the authorities section, and rest of the stuff is kind of like a template you can copy paste, but they have a meaning. What I'm trying to say is that the idea, the important point to note here is that the authorities string needs to be unique. It needs to be unique across all apps. If your content provider is same with another app, then things will not work out. So for this same reason, the green part that you see in the slide is the application ID part, is basically a manifest placeholder. What it does is that once the merging is complete, it will get the package name of the application, and it will replace application ID with the package name of the app. So then it becomes unique to your application. The package name reads the name of your application, the package name of it, puts it here and says .mylibrary. So your authority string, your content provider tag is unique for your application, even though the library that you are integrating, this is living inside your library, right? So the library doesn't need to worry about this, making it unique inside your application. Once you integrate it, it goes through manifest merger stage, and it kind of makes it unique by the end of it. So I keep talking about manifest merger in this state. If you did really want to see this, what you would do is that you will open up, you will build your application. And then what you will do is that you will open up the manifest for your application. And inside that, what you need to do is that you need to click the tab, which is at the bottom. It says merged manifest. Okay. Now, this is where you actually can see the provider that is coming from your library. So my application is called using content provider to init lib. This is my application name. And now what I have done is I've integrated, or I have added a dependency on my library. So it would probably say in the build.gradle as implementation, and then the name for my library, it could be com.example.mylib, and then the version number 1.0.0. And once I build the project and I open the manifest file, it shows me the provider that has got merged inside the actual and the final version of the manifest file. So in this case, you will see I've highlighted that inside the provider, in the authorities section, it actually says the package name of my app .mylibrary. So it says github.issues.example.using content provider to init lib .mylibrary. So once the application is actually built out, this provider is unique to that application because it has a unique authorities string. And on the side, on the right side, you can see that basically it says where does this provider come from? It comes from the manifest file of using content provider to init lib dot my library. If it came from, say, Facebook, it would say Facebook dash core manifest file. And that's how you kind of figure out how these values are coming in. So at this point, we have built out a content provider. Our library is able to initialize with the context. So what we don't need anymore is that one line that said mylib.init application context. And this whole setup in general was just an evolution of what it has come to be, where library developers would want to automatically initialize their libraries with a certain application context without the app developers having to write that line. So you don't need that one line that strike through anymore. Your code looks like this. You basically start your in your main activity, you basically start using the library right away. You say mylib.change token 123, mylib.change token 456, and then you get the value. You say mylib.get auth header, and this time your output is still the same. You get authorization : bearer 456. So all of this, when we talk about, is nice and good, but is this actually being used by other libraries? Yes. You can see that in AndroidX Process Lifecycle Owner, they do this content provider trick that we have been talking about. So they set up their own provider inside the manifest file. You can check out, there's a link at the bottom, which you can go and check out. Basically, it lives inside lifecycle-process module, and inside the manifest file, you can see they do the same thing. They set up a provider, and they need this basically because when you start your process, they want to hook into the system. They want to initialize the library as soon as the process starts. So it's a valid use case to actually use this. Work Manager, as you know, is also unique and has a valid reason to do it, because they want to schedule jobs for you, schedule your work for you. So in that sense also, it is very useful, and I think this is a valid use case for them to use it. Now, Firebase is the one who kind of publicized this. They made it aware how to use this. They wrote a blog post about this. So it makes sense that Firebase also is using this. They use it in the Firebase Common. So if you bring in any other Firebase dependency, they all depend on Firebase Common. So Firebase Common in general is using Firebase Init Provider to initialize Firebase right away. Now, Firebase needs to do a lot of analytics and other stuff, so it makes sense for them to do it. However, there are other library providers also who are using this, and they are also initializing them. They are starting their libraries. They are trying to initialize the library. So like Facebook being one of them, and it lives inside Facebook core. So if, say, for example, you are using Facebook marketing, for example, then it depends on Facebook core. So Facebook is anyways initializing inside your application using the Facebook Init provider. And this basically means that even if, say, for example, you don't even call anything related to Facebook, but you did integrate it in your build.gradle by just adding that line saying implementation, com, Facebook, Android, Facebook core, and then the version, then the library would initialize itself, even though you don't use it. Maybe they need it for analytics, maybe they need it for ads. Hopefully, whoever is integrating Facebook libraries, they know why these libraries are starting up and why this is required. But you can always go into the Facebook Init Provider class if it's open source and see what exactly they are doing. I'm not saying they are doing anything notorious. What I'm trying to say is that they are initializing without you actually knowing about it, or you actually initializing them on your own as an app developer. So using a content provider sounds like a unique thing, sounds very tricky. It sounds very nice that app developers don't have to initialize. Well, it does come with problems. The problems are the libraries are auto-initializing themselves, even if you don't want them. Libraries are invoked as soon as the process starts. We talked about this even before the application application class is initialized. The content provider is initialized first. Memory overhead because of these invocations. As soon as the initialization process starts, it tries to allocate memory. It needs to allocate memory to, I don't know, maybe set up some sort of a string, some objects that you will use later on. And then there are no order of init possible. Imagine there are like 5 of these libraries with their own content provider, unique authorities, triggering at the same time. Then it's not like one of them will finish initialization and then the other one would start. It's like all 5 of them would start at the same time. which has its consequences. Basically, all of them are running on the main thread, and this increases the startup time of the application. And you have a sluggish UX. You open the app and it takes a bit of time for the animation to kick in. It takes a bit of time for your app to actually load up the whole process and then show you exactly what you need, right? And at the end of the day, we all agree that it's actually abusing the functionality of Content Provider. Content Provider were basically built so that you could share data between different applications. But now we are basically using them to pass in a context and then initialize whatever the libraries would want to do it. So we know that there are some bad actors in the process. Some are good, process lifecycle owner, and then there's like work manager. They are good, but then there are some that we probably wouldn't want to trigger them, right? So how do you tame these bad actors? Well, the short answer is that you use merge marker rule. The way that you use it is that you need to define the namespace. So you say XMLNS, which is XML namespace, :tools, and then you give it the schema value link, and then you kind of use this tools : node equal to node equal to remove in double quotes. This is the actual tag that you will drop on your provider or on your actual XML tag in the manifest file, and this will basically remove the merge manifest file. So how does it look like? So here's an example. I'm basically showing you the provider for my lib init provider, the one that we saw earlier. And I've already set up the tools namespace. And what I've done is that I've added tools : node equal to in double quotes remove the marker on it. Merging stage to remove the provider. Okay. Because I'm talking about manifest merge a lot of time, and I'm saying there's a merge marker rule to remove something, we need to understand how this thing is actually working. Like, why is this that when you drop a merge marker inside the application's manifest file, then the final manifest file does not have that provider tag? So the merge priority, the way it works is that the lowest priority is the one from the libraries and Android manifest.xml file. This gets merged into the main Android manifest.xml file. Now, at this point, when within your main Android manifest.xml file, if you drop the provider with the remove marker, the merge marker removal tag there, then the libraries provider is already in there, and now you have marked it to be removed. So when it gets merged into the build variants manifest.xml file and then to the final Android manifest.xml file, the tag is already gone. It doesn't exist anymore because the priority exists. There's a library first, then the main, and then the build variant, and the final manifest.xml file. So all of this is a tool chain process. That's why you're able to do this. So at this point, it's worth mentioning that we have been talking about what Content Provider can actually do and why libraries are using this. So we've understood the problem that many of these libraries are actually using this out in the open, and they are triggering and they're making your applications slow, and the startup time is bad, and they're automatically starting for you. This is when AndroidX Startup comes in. People have different names. Some people call it Jetpack Startup. Someone will call it App Startup. I will call it AndroidX Startup. And it is basically part of Android Jetpack's suite of libraries. What this is basically is that it is going to be taming all these different libraries that are kind of triggering on their own. It's gonna make the life a bit simpler. We're gonna see how it does that. So from the original documentation, AndroidX Startup in general, what it does is it implements a straightforward, performant way to initialize components at App Startup. Okay, it's heavy words, but let's see what it actually does. So you can find the sources of this at this link that's in the slides. And an important milestone for this is that it's actually stable. It became stable last year on October 28, 2020. It's pretty new. We'll talk about it being new here, but overall it is stable. It's worth to be used, and library developers should start using this. But we'll see why library developers should be using this. So what does it actually do? It allows to initialize libraries without having to define a content provider on their own. Now, notice I would want to put emphasis on the part where I say not having to define a content provider on its own, because AndroidX Startup actually uses the content provider tag. Okay, so it will actually inject one content provider inside your application. But what it will do is that it will take away all the other content providers that were triggering at the same time, but rather control all of them through this one content provider that exists. So it's kind of streamlining the pipeline. Instead of saying everyone start up, it's going to say, I'm going to decide who's going to start up, which is where we come into the part of saying it allows you to lazy initialization and also define the order of initialization. You can define when a particular library needs to be initialized first. So how do you integrate this? Well, simple stuff. In your app or your libraries modules build.grader file, you kind of add this line, which is the signature of adding it from the Maven repository. So you will say AndroidX startup runtime, and then the version 1.0.0 for now. Hopefully in future it increases. We have more functionalities in there. And then now, instead of creating our content provider, we'll actually be creating an initializer. This is a specific class that Jetpack or AndroidX Startup provides. And you kind of create your own class. You say mylib initializer, and then you extend from initializer. You pass in the type of your library class. So in this case, it's mylib. And it provides you two functions, which you can override. There's one for create, which gives you access to context. So basically means that you can initialize your library right in there. You say mylib.init and then pass in the context. Simple stuff. But it also provides you another function called dependencies. Now, in this example, the one that I'm showing you right now, it is returning an empty list. But ideally, if say, for example, mylib.init, if this function needed another library to be initialized first, this is where we are talking about the order of initialization. If mylib.init needed another library to initialize before mylib.init gets called, then this is where you will actually mention it. You will mention it inside the dependencies function. So I'm going to give you an example here. So in mylib.init, before it can be called, we actually need myAwesomeLib to have been initialized upfront, right? So what we are going to do is that in the dependencies section, instead of returning an empty list, we're going to say list of the initializer of another library. So in this case, myAwesomeLib initializer would be called to initialize myAwesomeLib upfront, and then mylib.init would be called with the myAwesomeLib initialization. So it's a bit tricky. It looks like a tricky, but this is like a pattern. And you probably want to stick with the pattern because this is how they're defined it. In future, it might change a little bit, but not drastically. This is how the API structure is for the AndroidX Startup library. The good thing here is that we are able to control the order in this case. When you define a dependency on a certain initializer, then it will be initialized first, and then the final class would be initialized because it understands that this needs to be called first. Now, the same as in the case of the standard content provider, as I already mentioned, AndroidX Startup actually uses at least one content provider, or at most, I would say, basically uses one content provider. So you need to actually add this provider tag inside your library or in your application, depends on where you're using this. And then it's basically a template. You kind of do the same thing. You say AndroidX Startup initialization provider, which is the one that AndroidX provides. And then the authorities, again, it's a template. Basically, you say the same thing. The unique part, though, is that you can say tools : node equal to merge. You need to specify this because then only it will go and merge correctly, including the metadata. So the metadata is where your own initialization goes. Anything above that is a template. You basically do the same thing every single time. And I'm oversimplifying this. It's useful. But what I'm trying to help you here is that if you were to integrate this, you don't have to worry about the actual provider tag, but the metadata part is where you actually need to put your library initializer. So we created mylib initializer. So that's why we are giving the full package name of that. And then the value is still the same. AndroidX.startup is pretty much the same. What AndroidX Startup does is actually reads this metadata value and it tries to find the class from here. the unique part here is that you just need to mention the topmost library. Any dependency under it is actually discovered within the dependencies section that we defined inside mylib initializer. It sounds like a lot of inception based thing, but it's not. It's basically a lot of like dependencies that we are talking about. Another thing that you can also do, we keep on mentioning that content providers run specifically on the main thread, but technically you could actually change the process of them triggering on the main thread. You define that by defining the process attribute and then giving a process name. However, this is not like, I wouldn't recommend you doing this, because when you start jumping processes, you do a lot of different things. You have to do AIDL, you have to do inter-process communication, and a lot of complexity comes into play. So you don't typically want to do this, but it's a possibility. You can switch your process to a different one than being the main thread. Now the question comes in that, okay, up till now we had content provider trick that other libraries were using, and we could tame the bad actors then. But what if some library integrates AndroidX Startup, and I want to disable the init of a specific library within it, right? So AndroidX is triggering one of these libraries, but you as an app developer want to control it. So the way that you do this is that inside your app's manifest file, you copy paste the exact same provider that you see in the merged version, but in the specific library that you want to disable, you go and add the tools :node remove marker. Now, what this means is that when the manifest merging would complete, that metadata tag would be gone. So AndroidX Startup would not know where to find the initializer, and then it will not trigger the initialization of that particular library. But what if you actually wanted to remove all initialization that AndroidX Startup is doing? Imagine AndroidX Startup is starting up 5 libraries, and you found out by looking at the merge manifest file. So you're like, I don't want this AndroidX Startup to be doing anything at all. So what you do is that you, instead of putting the tools node remove marker on the metadata tag, you will actually put it on the provider the same way as we did earlier in taming the actor section. You're basically getting rid of the whole provider. So even AndroidX initialization provider is not going to exist. So nothing is going to get initialized. But what do you do when everything is disabled? Well, then you have the possibility of overriding the whole AndroidX Startup automatic initialization process, but rather you have access to now something called a manual initialization. And this is important because this is where lazy initialization happens. You have access to this class called app initializer. You can get the instance of it, pass in the context, and then initialize the component by triggering your own initializer or another library's initializer, if that exists. Now, why is this important? The important part here is that imagine that right now your application starts 5 libraries at the same time using AndroidX Startup in order specifically, right? Now you don't want that to happen, because when it does that, then your application starts slow. You have some sluggish UX, things don't work out as you would want it to be. So what you can do is that you can disable completely AndroidX Startup, automatic startup. And what you can do is that when the application is loaded completely, then you specifically on your own manually use app initializer class to initialize your libraries one after the other. Or you don't need to initialize 5 of them at the same time. You can initialize 2 of them at one point, go to another screen and initialize another 2 at a later point in time. This is where lazy initialization comes in. And it's a very strong functionality. The ability to do manual override is something that sets AndroidX Startup apart. Super nice to do it. So how good is it? Well, we already talked about a couple of these points. Basically, AndroidX Startup allows you to do dependency init in order. It allows you to do lazy initialization, which is also great. Uses a single content provider, still uses one. Comes with a lint check. So sometimes if you are making some mistake, you can do a lint check and you would be like, the compiler is going to help you out. The bad part though is that it still uses a content provider trick, still abusing the content provider. And there's no support for asynchronous initialization. It's still happening synchronously. There is also nothing at least for now, there's nothing for multi-process in it. I think there was a bug report on this, and the library developers said that this is by choice. This is a design decision, but maybe it changes, right? For now, at least, it does not support multi-process initialization. If you go on the bug tracker, this is basically a screenshot of their bug tracker. There are not a lot of like very big bugs, as we will call it. They are like small bugs. And if you do find some bug using them, please go ahead and put this in the issue tracker. It would be helpful for them. So are devs actually using this? The short answer is yes. There are a couple of libraries that are already using this. There's What the Stack, there's Sentinel, Phonemoji, RetroAuth, TikTok. All of these libraries are using this, which is great because as more library developers use this, the situation where all libraries are starting up on their own is going to get better, and not all of them will start on their own. You have control as an app developer. You have more control on how libraries are starting up inside your application. So what's next? Well, the first thing that needs to happen is that AndroidX libraries need to be migrated to Jetpack Startup or AndroidX Startup. Work Manager, Firebase, the process lifecycle owner, would be nice to have them also part of using AndroidX Startup. But for now, as we already know, they use the native content provider, which means that if, say, for example, you have process lifecycle owner, work manager inside your application, then both of them will start at the same time when your app opens up. But if they were using AndroidX Startup, then you could control that, for example, process lifecycle owner starts up first, and then work manager starts up. That's something that you could have controlled, but as of now, you can't do it. You have to do some loopholes and hacks to work around this. And then the idea is that hopefully more library developers would start using Jetpack Startup. The more people use this, the better it would be. So at this point, I do want to mention that all the examples that I mentioned, they all live in the GitHub repository that I already have. This is called Android lib init examples. This is on my own profile in issues. It has all the examples that we discussed, so you can run them. These are small isolated examples. You can take a look how the modules are set up, how the dependencies are set up, and how they all work. So there's examples like normal class constructor to initialize a library, using an init function, using LifecycleObserver, Singleton, ContentProvider, and then finally using AndroidX Startup. All these examples are available for you to try it out and maybe figure out how these are functioning, and maybe put in more debug points if you want to find out extra information about it. And one last thing that I actually want to bring it up is that we have been talking about how libraries are starting up and how do we tame them, how do we figure out ways, and how AndroidX Startup is actually helping us out. But we never talked about how do you actually measure your app's startup performance. Like, okay, we understand that our app is starting up a bit slow, and there's libraries triggering on their own, and there's also other things that are also contributing to the sluggish start of your application. But how do you measure that? So for that particular case, it would take another hour to explain the whole process. So what I did was I basically have linked a blog post from Chet Hase, who's basically on the Android Tools team. This blog post is called Testing App Startup Performance, where he goes into detail how you actually do it, how you figure out how do you measure the time it takes for your app to start up, and then how much time it's taking, basically, right? And that, I mean, for the short version, I can actually tell you what it would look like. I kind of have a bash function for this, and then there are other ways of doing this. So if in practice, the way that you would actually test your particular application and how many times it's run, so what's the time it taking for startup, you will say something called check startup time, pass in the package of your application. You can see in the top where I say usage, I say check startup time, package name, com.example.myapp, and then the launch activity. So in my case, it is the main activity. So that's why I'm mentioning main activity. Now, how is this even working? That's where the function comes in. What the function is actually doing is that it's going to loop through 100 times from 1 to 100. And what it will do is that with adb shell am-force-stop, it will try to read the total time it takes, and it will print it on your screen. Now, this is just one example. This is basically the same example that Chet Hase uses in his blog post. So it's something that you can obviously read. He also talks about locking the clocks, and there's like a bunch of different things. There is another tool that you could use, but you would have to use like some more tricks around it. There's something, it's a Rust tool that people use for benchmarking. This is called Hyperfine, if I am not trying. So yeah, the Hyperfine will basically calculate the time based on how many times you have run a certain thing. So you could start the activity and force close it, and then it will calculate the time difference by running it, say 50 times or something. So there's many possibilities of how you can measure the time, the startup time for you. The idea is that you should measure the time and figure out what's actually happening with it, because application developers in general just integrate the library and they forget the side effects that it comes with. So sometimes just adding two libraries, for example, you adding just Facebook library could just increase your time by, like, say 1 second. I mean, 1 second is a lot of time, but let's say like a couple of milliseconds, 100 milliseconds or something, which is a time penalty. You don't want that to happen. So the idea is that eventually you figure it out, what's causing that much time problem. Actually, Chet also has another blog post regarding AndroidX Startup, where he shows when you add a library, how much time difference it is when you actually remove the library, or when you do AndroidX Startup based setup of the library, or when you do manual initialization, the way that we did at the end of these slides. So he kind of talks about which is the best way of doing this, and you should probably try to do the same thing so that you can figure out what's the best version that works for your application. There's no silver bullet by saying that you just remove all the content provider, you put AndroidX. Maybe some libraries don't even support it. So you need to measure that time. And to do that, you need to read that blog post, or maybe we can discuss about like how it actually works. But this is an intricate process. It does involve a lot of discussion around how applications start up in general, and then how do you measure them. Hopefully there would be another talk on this one. And I guess that's it. So if you want to reach me, you can definitely find me at @NISRULZ, and the same username for my Gmail, for my website, and on Twitter, all the same. If you have any questions, please go ahead.
Thank you, Nishan. That was a very interesting session. I myself learned a lot. Can you hear me?
Yes, I can hear you.
Okay, we have a bunch of questions.
Nice.
And comments. So that's the first. Good knowledge share.
Nice.
And that's a question.
Okay, I can read it. Is it possible?
It's on the screen.
Oh, okay. I see it now. Yes. Okay. I mean, if the library is open sourced, you can do that. So like if you're saying if a library is created in AndroidX as a module, so AndroidX libraries are open source. Yes, you can take those libraries and you could add them. So for example, I guess your point is that if process lifecycle owner, the lifecycle dash process library does not support it right now, right? Can you take the module and use it? I guess you could. You probably need to figure out the dependencies. So lifecycle process lifecycle owner also has its own dependencies. So you need to pull those modules also in. You need to figure out if you break anything, because I believe these libraries are also pulling in some code from other modules, like some common code, which is why they live inside a mono repo for GitHub. So that's why it's not a good idea to pull down existing AndroidX libraries. But if, say, it's another library, imagine it being Picasso, right? Picasso or Coil, you could just take that whole code and just integrate it if you want to, and migrate it using your own version. A better solution, though, is that instead of doing all of this trick of bringing the module in your project, you actually open a pull request with integration of AndroidX Startup. We just learned how to do it. If you open up a pull request and they accept it, then everyone benefits in the community. Whoever wants to use it, they directly use it the way they want to. They don't need to pull in the module for this.
Okay. And the next question.
Yes. So you can't figure it out from the Gradle dependencies per se. But what you can do is that once you have integrated the dependency inside your build.gradle, you run the build, and then you go and check your Android apps manifest file and click on the merged manifest tab. This is where you will see those extra provider tags. And if you click on the provider tag, on the right, it shows you where the provider tag comes from. So it could be coming from Facebook, it could be coming from, I don't know, Coil, or any other library that uses that. So you can refer it back to which library the content provider came from.
Okay. And I think it's the same person. Any side effects of compiling for Admin?
I don't think so. It has any implications because the manifest file is still the same for APKs and for app bundles. There is no difference in terms of the manifest file. The whole trick of content provider goes inside the manifest file, and it works from there onwards. So this does not have any side effects.
Okay. And
okay, this is a good question. So the question is mostly about why don't we just initialize it in a different thread? Like, let's say thread coroutines is a different topic in general, but let's say it's in a different thread. I mean, you could totally do it. You could use the manual override version that we just talked about in the presentation. The thing with that is that when you do it and you trigger it up, how do you get the data from the library that's already initialized into your main thread? So if, say, for example, you were coroutines actually has a very good approach where you can switch context. You can go from, say, dispatcher.io and then come back to dispatcher.default or main. So that's a very good way where you could actually jump between coroutines. You could totally do it using the manual override. But if you had to auto initialize it, I don't think so you have much control there because AndroidX, first of all, does not provide you multiprocess, as we already talked about it. But it does provide you manual override where you decide where to initialize the library. So if you did manual, you can totally do it. When you're talking about threads, then you need to figure out how do you come back to the main thread where you will actually use the library. That's why people don't do it. With coroutines, maybe it is possible. I haven't actually tried this out, but it sounds like a good example that I can put in my GitHub repository, which you can check out later on. And I will add an answer to this question because it sounds like a very good one. People would have this. Thank you for asking this question. How to use it with multiple libraries? Okay, so if the library is already implemented AndroidX startup libraries pattern, they have their initializer in place already. So you typically don't have to do much. They already did the work for you, and your library is already started. But if it's your own libraries, then you need to create the initializer and you need to create the providers and everything in your own libraries. So if I'm understanding the question correctly, then if you want to use it with multiple libraries, you need to create the initializer for each library. And you need to add the manifest, and you also need to integrate AndroidX Startup as a dependency. So then anyone else who uses it would typically use this right away. I guess if that doesn't answer, maybe you can ask the question again and clarify it. Okay, yes. I will share my slides with the team, GDG Helman. I will basically do that, and so you can have access. But you can also find them on my website and also on my blog post and also on Twitter. Any other place that you can find me, you will usually get the link. But ideally, your GDG would share it with you. I guess maybe we'll put it in the YouTube comment section, also in the description, so it might work for you. And some of the
share the
topics,
slides.
Yeah, and some of the topics that I would suggest to get deep dive on this topic is that So library development in general has a very vast surface because app development is isolated to your own application. But when we start talking about libraries, then this is component that goes into any application. So what you want to do is that you actually want to start looking into how other libraries are first built, right? A good way of trying to understand this is reading up articles from other library developers, maybe looking up at pull requests of other famous libraries, like for example, Picasso was doing this LifecycleObserver trick, right? So if you read that pull request, you will get, oh, this is how they do it. You could go ahead and read the source code for OKHTTP, which is also a very nice library. If you want to get into multi-platform libraries, you have Ktor, so you can also look into that. There are many libraries. Just look at the source code, read how these authors are also talking about on their blog post, or they are giving talks. Like for example, I'm giving a talk here explaining how the initialization process works. Someone else would be giving another talk on, say, how the APIs needs to be built so that they are backward compatible. So these topics are very varied. A lot of this information is not as widely talked about, but it's happening now. More people are talking, more library developers are starting to talk about. There are many talks that you can get, at least from last year and this year, and even 2019, I guess, where people started talking about how to be a good library developer, how to be a librarian, for example. If I remember, this was from some US conference. So there's always some content. Just search for Android libraries, and then you can find content for that. Okay, yes. Can we enable disable initialization of runtime instead of? I think so you can actually do that because if the content provider tag exists inside the manifest, it's the first thing that's starting up. So even if you wanted to do something on runtime, it's already has been done before your application class loads up, before your activity loads up. So you can't kind of technically disable it on the runtime, but what you can do is that you can basically get rid of the whole initialization from the manifest, and then you can enable or disable it using the manual initialization. So you have this app initializer.class where you can say .get instance and then initialize. So basically, you at least need to get rid of the auto initialization. This is the whole problem of auto initialization, that you cannot control it. And this is why AndroidX Startup jumped in and they said, okay, we're going to make things easy for you. So you basically want to disable auto initialization and then take control of how library starts up. And if you don't want to start it up, you basically just stop using it, deallocate it, set it to null or something. Probably the library provides a way of cleanup also. So it's all on you. It's your choice, but the base provider tag needs to go away because that's something that you can't control from triggering. And how if each library has different dependency? Maybe I don't understand the question as well. But yeah, it would be nice if you could like clarify on what you're suggesting about different dependency.
I think it's a follow-up question for this question.
Okay. And okay, let me just think of this one. Each library has different. Okay, yes, I get the question now. Okay, so if every other library has a different dependency, some of them depend on Jetpack Startup, some of them don't depend on Jetpack Startup. They do their own content provider. Then at the end of the day, they are all still getting added in the merge manifest. And this is where you actually start taking control. You basically say, I want you to stop doing what you're doing. I am the one who's going to be initializing you. So I'm the one who's going to take up the initialization process, and I will do manual initialization. This is a very chaotic situation where others are doing something else, and then some are actually following the correct route. But there's no correct answer to this. The point is that the ideal scenario would be that everyone actually uses AndroidX Startup, or they just don't use content provider trick. They allow you to initialize your library on your own. Okay, I think what we are saying is that how do we make sure that the dependencies are initialized before your library gets initialized, right? So okay, so in that case, what's going to happen is that we already actually talked about this, that you initialize your library in the onCreate, yes, but there's another function for AndroidX Startup called dependencies function, which you override. This is where you mention other dependencies you have. So you don't ever initialize specifically all these other libraries, because these libraries have their own initializer class. They have their own onCreate and on dependencies functions. So what you are doing is that in your main initializer, your library initializer class, in your onCreate, you say mylib.init, and then you basically just pass the instance of your library, the other dependency you have. But in the dependency function, you say go ahead and initialize other libraries first before you even go and initialize the onCreate library, the mylib library. I mean, I think when I say it, it sounds very confusing, but the general idea is that you have your first library, which depends on another library, and there's another one. So onCreate works with this library, but dependencies would work with these. Now, these sub libraries that you list in the dependency have their own initializer. So at the bottom, they also have an onCreate and they also have dependencies. And the way that AndroidX Startup works is that it works from bottom to top. So it tries to initialize the lowest first, goes on to initialize another one, to another one, and then to the very end, you have this last library, which it will initialize at the last, because all of them have been initialized. So it's like a bottom to top approach. Just make sure that by the time you reach the top, all the other dependencies are initialized. I hope that answers the question.
So that's the end of the questions.
Okay.
And I want to let anybody knows that the session is recorded on that link. So if anybody want to take another look, and we would like to thank you, Nishant. It was very, very interesting and informative session.
Yeah. Thank you.
Thank you for your time, and thank you. And we will share the slides with everybody in our Facebook page and in a comment in the YouTube channel. So thank you, Nishant, and it was nice to having you with us today.
Same here. Thank you.
Thank you. So ممكن بقى نقلب عربي تاني. شكرا يا جماعة لكم. النهارده كان سيشن دسمة زي ما شفتوا ومع باشمهندس نشانت، وإن شاء الله معاكم بكرة ومكملين في الساوث كايرو تيك توكس. نشوفكم بكرة. السلام عليكم. اوكي. جود باي نشانت.
Goodbye.
Goodbye.